Today's notes are on graphing quadratic functions in standard form, vertex form, intercept form, and graphing quadratic inequalities. Standard form is an equation y equals ax squared plus bx plus c, where the vertex is the ordered pair x comma y. In order to find x, you are going to use the formula x equals negative b over 2a. Once you find x, you're going to plug it back into the equation in both spots for x, and you're going to solve for y. Then, once you have the vertex, you are going to use a table to find more points. Vertex form is y is equal to a times the quantity of x minus h squared plus k, where again the vertex is x comma y. In order to get x, you are going to solve the x minus h portion of the equation, set it equal to 0, solve for x, and your y value is equal to the k value on the outside. Then once again, you're going to make a table to find more points. Some characteristics of quadratic function graphs. If the a value is greater than 0, so either the number in front of the x squared or the number in front of the quantity, your parabola opens up. If a is less than 0, your parabola will open down. The parabola is wider than the graph of the parent function y equals x squared if the absolute value is less than 1, and narrower if the absolute value is greater than 1. As you saw in the definition for standard form, the x-coordinate for the vertex is negative b over 2a, and the axis of symmetry is the vertical line x equals negative b over 2a. Let's scroll down and look at the first example. Your steps for graphing quadratic functions in standard form are first, find and plot the vertex. So for step 1, I'm going to be using the formula x equals negative b over 2a. So I have the negative, my b value is negative 8. So here we had a, which is the number in front of the x squared, is 2. B is the number in front of the x, so it's negative 8. And c is a positive 6, so negative b over 2 times a gives me 8 over 4, or 2. To find the y value of the vertex, I'm going to plug x back into the original function for x. And I find that y is equal to negative 2. So my vertex is the point 2, comma, negative 2. So I'm going to go ahead and plot that. Step 2 is to draw in the axis of symmetry. Your axis of symmetry is going to be the line x equals, and then whatever the x-coordinate was of your vertex, so x equals 2. And we're going to draw it in with a dashed line. Step 3 is for us to plot 2 points on one side of the axis in symmetry, and then use symmetry to plot 2 more points, or as we had stated in our steps above, we are going to create a table. So you want 5 values total. And in the middle of the table, you are going to put your vertex. So the points 2, negative 2. Then I want to pick 2 x values to the left of that point, so 1 and 0, and 2 to the right, which would be 3 and 4. You are then going to find the remaining y values by plugging the x values into the function, similarly to what we did in step 1 to find the y coordinate of the vertex. If you do this, you'll find the y values that you're missing are 6, 0, and then 0, 6. If you use the vertex in the center, it should happen where the values on both sides are going to be symmetric. So I'm going to go ahead and plot those points. And then we can draw a parabola through our plotted points for step 4. So it should have a U shape to the graph when we are done. Please flip to the second page and try example 2 on your own. After you have tried example 2, we're going to be looking at the steps for graphing quadratic functions in vertex form. Our first step is going to be to plot the vertex, which is the point h comma k. So our first step is going to be to solve the quantity x plus 3 by setting it equal to 0. So we find x is equal to negative 3. That's going to give us the h coordinate of our vertex. The k coordinate is the number added or subtracted to the end of the equation. So our vertex is the point negative 3, positive 4. Then from there we're going to draw on the axis of symmetry. So this is going to be the point x equals negative 3. It should always go through the center of your vertex. And then step 3 says use symmetry. We can also use our table. So we have 5 values on the table again, with our vertex going in the middle. So I'm going to pick 2 values to the left of the vertex and 2 to the right of the vertex, and plug those back into the original function in order to get the y values. And I'm going to plot the remaining points. So negative 4, 3.5, negative 5, 2. And I'm going to reflect those points to the other side. And connect them to form a U shape for our parabola. Please follow these steps and try example number 4 on your own. Our next form that we're going to look at is intercept form. It is in the form of y is equal to a times the quantity x minus p times the quantity x minus q. In order to solve for x, you're going to set x minus p equal to 0 and x minus q equals 0, and you're going to solve both equations for x. Your vertex is once again going to be the point x comma y. In order to find the x, you need to average the two x-intercepts. So you'll add them together and divide by 2. Once you get the x value, you'll take it and plug it into the original equation for both x in order to solve for y. In order to graph, you do not need a table. You're going to plot the x-intercepts and the vertex and use the 3 points to make a parabola. Let's follow along with the steps as we go through the next example 1. Step 1 says find and plot the two x-intercepts of the graph. So in order to do that, I'm going to set x plus 2 equal to 0 and x minus 4 equals 0. And I'm going to solve them both for x. These are the x-intercepts, so you can write them as ordered pairs. Negative 2, 0 and 4, 0. and I can go ahead and graph those. Then I'm going to find the axis of symmetry, which lies halfway between the two x-intercepts. This will also allow me to do step 3, which is find the x-coordinate of the vertex, because it will be the same as the axis of symmetry. So I'm going to add -2 and 4 together, and I'm going to divide them by 2. So we find x equals 1, which is our axis of symmetry. It is also going to be the x-coordinate of our vertex. In order to find the y-coordinate, we are going to plug this back into the original equation and solve for y. So we get y is equal to -1 times 1 plus 2 times 1 minus 4, which if we simplify we get 9. So the vertex is the point 1, 9. Once you have these 3 points, you can go ahead and connect them to form your parabola. When you're done with example 1, you can try example 2 on your own and then take a look at the next page, Graphing Quadratic Inequalities in 2 Variables. Your steps for graphing a quadratic inequality is to first draw the parabola with the equation y equals ax squared plus bx plus c. So you're going to use your steps from standard form on the front of your packet. Then you're going to make your parabola dashed for inequalities with less than or greater than, and solid for inequalities with less than or equal to or greater than or equal to. Next, you're going to choose a test point, xy, inside the parabola and check whether the point is the solution of the inequality. Once again, the point 0, 0 works best unless it is on the parabola. If the point from step 2 is a solution, you shade inside the region. If it is not a solution, you shade the region outside of the parabola. So let's go ahead and follow our steps from graphing. The first thing we did was find the x value using the formula x equals -b over 2a. So we need to identify that our a value is 1, b is -2, and c is -3. So here's -b over 2 times a. I get positive 2 over 2, or 1. So we know that that's going to be the x-coordinate of our vertex. In order to find the y-coordinate, I'm going to plug 1 back into the equation for x. And we're going to get -4 out, which gives me the y-coordinate of my vertex. So I can plot the point 1, -4. Now that I know the vertex, I can create a table of values. Again, you want to put the vertex in the center of your table. And I'm going to pick 2 values to the left of the vertex and 2 to the right of the vertex to finish my table. And I'm going to plug the x values in and solve for y in order to complete it. And I'm going to plot those points. Next, I need to look about whether I'm going to have a solid or a dashed line. Based on the inequality symbol, we're going to have a dashed line, so I'm going to form my parabola using a dashed line. Then I can continue on with step 2, which is to choose a test point. And I'm going to pick 0, 0 since it does not lie on the parabola. So I'm going to plug 0 in for y and 0 in for all of the x's. And I'm going to simplify and get 0 is greater than -3. This is a true statement. So because it is a true statement, it's a solution, which means I'm going to shade inside the region of the parabola. Had 0 greater than -3 been a false statement, we would have shaded outside the region of the parabola. Try example 4 on your own. We will look over example 5 on the next page together in class.